Good evening and welcome to today's live session for the subject Strategies for Sustainable Design. Uh, Very few people have joined and some are still joining, so I'll wait for 5 more minutes, see if more people join, and then I'll start the session. It's 5 minutes. I think we should start the session. So, welcome everyone to today's session for the subject strategies for sustainable design. This is the third session for week 3. So, this week we'll be discussing problems that have been covered in the week 3 of lectures. So, this would have been the lecture on relevance of sustainable design in contemporary contexts. So this would have explained you the context of present day environment and anthropogenic activities that have rendered certain impacts on our living environment, because of which sustainable design uh, is relevant in our current context, and why we need sustainable design strategies to limit or mitigate the impacts caused from the anthropogenic activities and the harm that human activity has caused to the environment. The next lecture would have been on the built environment and energy consumption. In this, you would have had an introduction of how the built environment is associated with consumption of energy. So, what are the different aspects of energy consumption associated with the built environment, and how uh, each of the things can be dealt with in our design exercise. Next, we would have studied the reliance and dependence of building design on energy. So, how the design of the building uh, influences the energy consumption, both during the planning and design of the building, and later on with the use of the building. Next two lectures would have been on the current scenario of sustainable design in the Indian and international contexts. This would have showed you several examples of uh, sustainably designed or energy efficient buildings, both from India and from other countries, which would have given you an overview on what are the different types of design pathways we can take while we are designing sustainably, or we are designing for a sustainable built environment, or for energy efficiency, maybe for cost effectiveness, a lot of the things. So this is what we have covered this week. So the questions that we'll take would be related to these lectures that have been covered this week. Okay, so let's start with the first question. So the first question is, what is the percentage of total world energy consumed by the building sector? And you have several options: 35, 40, 45%, 50%. Okay. So basically, this question is talking about the consumption of energy by different sectors, and what percentage specifically the building sector consumes in that. There is another similar question which asks, so this question is not was not there in the previous run, but it is a question from another run, which is very similar to this question, because it again talks about energy consumption sector wise. So, what percentage of energy is consumed by different sectors? So, this I showed you this because this is another kind of example of a question which might come in your exams, or which might be there in your assignments, and it is relevant because it is again an example of the same sector wise division of energy consumption. So both these questions talk about what is the total energy percentage consumed by one particular sector. So either it is talking about the building sector in general, so what is the percentage consumed by that, or it is talking about which is the highest consumer of energy, and then related to that, which sector has the highest potential for energy saving. So in the lectures, this is what I found, that the energy consumption, sector-wise energy consumption was studied in the context of the United States, not in the context of the entire world. However, the question that has been given to you talks specifically of the total world energy consumption, not of the US. So if you talk about the US, the the building sector accounts for almost half of the energy consumption. So if you go according to that, it would land somewhere around 45% or 50% if you calculate from this. However, this question is related to the total world energy consumption. So for that, I have provided you some sources which tell you about energy consumption around the world. However, I could not find any source which specifically gives information about sector-wise consumption of energy. So the only information about sector-wise consumption of energy comes from this graph in your lectures, and this is in the context of the United States, not the entire world. So I think there might be some confusion around this question, and this question is not there in your current assignments. So I'll just tell you the background, and I'll tell you how to go about solving. So if this kind of a question is asked to you, and this is the graph which you have available as a background material, so you can see that for a particular year you can see what is the consumption of energy in a particular sector, and then you can add up all the energy consumption in each sector, and you can then calculate what percentage of energy has been consumed in one particular sector. You can calculate the percentages. Additionally, there is also a lot of relevant information available. Like here you can see that building sector accounts for almost half of the energy consumption in the US. Okay. Or building specifically accounts for over 70% of the electricity consumption, and over 40% of the CO2 emissions, etc. So if you're going particularly about USA, then you know that 45%, if you calculate, that is the answer to this question. This is the source of this information. So if you want to get little detailed information about energy consumption in USA, you can refer to this website. I have linked it for you. However, because we are talking, this question is talking about total world energy consumption, so for that you can refer to this data as well. So this is the data about share of energy consumption in the world by source. So you can see this is the energy change in energy consumption over the years, which is produced by oil, produced by coal, produced by gas, hydropower, nuclear energy, wind, solar, and other renewables. Okay. Similarly, there is a lot of data available here, maybe which calculates the absolute annual change in primary energy consumption, then maybe annual change in energy consumption from one particular source, for example, coal. So this is an example of change in coal energy consumption. So you can see in several forms. You can see from the table, so how the energy consumption has changed for each city. So you can get the data in a table. You can see in a map as well, so how it has changed for different countries around the world, and then you can even see for in a chart, so how has it been for the world, for China, Spain, Australia, Poland, and United States, which are the largest consumers of energy produced from coal. Similarly, you can find a lot of information about energy production, energy consumption from different sources, etc. Only drawback which I find here is that I could not find any reliable data for the energy consumption of the entire world uh, uh, according to each sector. So how much the building sector consumes or the industries consume. So the data for that is available for particular countries, like for USA or for China, the data is available for, but I couldn't find any reliable data which shows how much energy is being consumed by a particular sector in the entire world. So if you have further questions about this, or if you have a similar question in your current assignment, you can feel free to ask in the forum, because this is what I've gathered so far, that the lectures share the information about the energy consumption of USA, but the questions are asking about the energy consumption of the entire world. So I'm sorry that I cannot really provide you exact sources of or exactly which sources to consider to answer this question. However, I can tell you that if they are talking about the United States uh, uh, energy consumption by sectors, this is the data that you should be focusing on. And if they are talking about general energy consumption for the entire world, this is a reliable source of data which you can consult. Okay, moving on to the next question, which is which area. Okay, another thing which I wanted to tell you, that this is a similar question, that which are the two sectors which have the highest potential energy savings in the world. So in the lectures it has been uh, discussed that as building sector is the largest consumer of energy in the United States and in a lot of the world, and buildings not only use a lot of energy, but they also use a lot of resources, among which energy producing resources has a large share, and it also is a source of emission of a lot of pollution. So because of this, building sector and industrial sector both uh, are one of the highest users of energy, and have the largest share in emissions, and because of that they have the highest potential in which energy savings can be accomplished. So this question is related to that, so I just had this as an example if you wanted to know. So that is the rationale that has been used in the lectures to drive at that why building and industries are the sectors which have the highest potential for energy savings. Okay, moving on to the next question. So next question is which area in the building energy and use consumption is highest in the cold climate, and you have several options. Is it space cooling, is it building heating, is it water heating, or is it lighting? So another question which was there in an earlier run, it is also similar to this question, and it asks that energy, what percentage of energy is used in water heating in warm climate countries. So you see, this question is asking about a uh, building energy uses in cold climate countries, and this is a question which is asking about energy usage in one particular activity in a warm climate country. So uh, these both questions are based on this figure, which tells you about the general percentage or percentages of energy used in different activities in both cold climate countries and warm climate countries. So for example, in this question it asks that which area in the building energy and use consumption is highest in cold climate. So you can see this is the chart which represents energy usage in the cold climate countries, and you can see that this is uh, this is the share of energy used in space heating, which is 45%. So the largest amount of, or the largest percentage of energy that is used in cold climate countries is used for space heating in the buildings. This is quite different from the buildings in warm climates. So you can see the energy used for space heating is comparatively very less to building in a cold climate. The largest amount of energy used for a building in warm climate is for cooking, which is very less compared in a country where the climate is cold. The largest amount of energy consumed uh, in cold climate is then again space heating, and for uh, warm climate is 38. Even for cooling, space cooling, the amount of energy that is being used in warm climate is comparatively very less uh, than compared to building in cold climate. So I think it is very clear that which of these functions uses the highest amount of energy in a building in a cold climate. Again, if you see this question, this is asking that what percentage of energy is used in water heating in warm climate countries. So you can see here for water heating, this represents the water heating. 30% of the energy that is used in buildings in warm climate is used for water heating. This again is quite different for the percentage of energy used in cold climate countries, which is only 15%. So I hope this is clear. We move on to the next question. Also, we discussed this report earlier also in weeks 2 session also, but I just want to let you know again that this chart actually comes from a report from WRI. So this is the report. This is a report on accelerating building efficiency, and it suggests action for urban leaders. So what actions urban leaders can take for achieving sustainability in building design. So this is uh, the report from where that metric or that chart comes from, that what amount of energy is being used by buildings in warm and cold climates, and for what particular uses, what percentage of energy is being used. So you can see here, this is the diagram, and this is in the section understanding your building stock, and this section actually discusses about the different policy paths to transforming buildings and bridging the efficiency gaps. So this basically discusses that uh, which are the areas in which most attention should be paid in different climates, and in countries with different climates, which areas should be focused on more while we discuss energy efficiency in buildings. So the area where the most energy is being used varies from climate to climate. That is why the policies that we devised for energy efficiency in different countries also needs to target different areas, and this is how we can use the relevant information about energy usages to identify what are the policy gaps or what are the efficiency gaps where improvement in energy efficiencies can be made. Okay, coming back, give me one moment. Okay, coming back. So the next question is, Griha, the building rating tool, has achieved 65% reduction in water consumption by adopting which of the following techniques. So I do not know about the exact percentage which this question mentions, which is 65%. But I can tell you that Griha, which is a building rating tool, it has various uh, sections under which points can be awarded to a building based on how the building performs in that particular sector. So based on that, what amount of reduction of water or water consumption has been achieved by the particular building enables the building to gain certain points. And this question is talking basically about that. So GRIA is basically it's a standard or guidelines for integrated habitat assessment. So not only the building but even uh, the environment or the built environment in which the building is located. It provides assessment for that as well. So it's a rating tool that helps people assess the performance of the building against certain nationally acceptable benchmarks. So against that benchmark, how the building performs, Griha guidelines helps you evaluate that, and it is done uh, holistically for the entire life cycle of the building. So starting from the planning and designing of the building, moving on to further construction of the building, then operation and management, even leading to uh, up to the end of the life cycle of the building, which is the demolition of the building and uh, management of the waste uh, from the demolition of the building. So the rating system is based on accepted energy and environmental principles that seek to strike a balance between the established practices and emerging concepts of energy efficiency and sustainability, both on a national and international level. Okay. So these are the various aspects for which Griha uh, uh, provides points. So it can be uh, sustainable site planning, it can be for construction management of uh, the building during the construction process, then it can be for energy optimization, so focusing on what level of energy efficiency the building is attaining, then for occupant comfort, so what arrangements or what uh, options the buildings provide for comfort of the occupants of the building. For that also points can be awarded. Then for water management, again points can be awarded. Then for how the solid waste produced in the building and during the entire process of construction and then occupancy, how the solid waste will be managed, again points can be awarded for that. Then for sustainable building materials, so the building material that are being used in the construction of the building, if they are sustainable or not, based on that again points can be awarded. Same for life cycle costing, so for the entire life cycle of the building starting from the construction to its decomposition, again more points can be awarded. And then for socioeconomic strategies that are employed for the building construction and occupancy, you can get points for that also. Then again for performance metering and monitoring of the building, that if what we decided uh, initially that this is how the building will perform, so this is the energy efficiency that we expect from the building, this is the amount of water consumption, or this is the amount of solid waste disposal by such and such means. You can even meter and monitor that if what you planned, if those standards are being met or not. So again, you can, if you have set up systems to meter and monitor that, you can get points for that as well. So if your project or your building gets from 25 to 40 points, you get a 1-star rating. If the building gets 41 to 55 points, you get a 2-star rating. If the project gets 56 to 70 points, it gets a 3-star rating. 71 to 85 points is a 4-star rating, and 86 or more points is a 5-star rating. So this is how ratings are done in the Griha rating system. This question particularly asks about the rating in the water consumption section. So I have linked the Griha manuals and the manual for self-evaluation. Using that, you can even self-assess if a building uh, is if it meets up to the benchmarks of Griha or not. So I'll just show you that. So if you go to the self evaluation checklist, you can see here there are evaluation checklists for affordable housing, for existing buildings. Then there is a 2015 feasibility checklist, which is the older one, and then there is a newer one, which is the 29 feasibility checklist. Then there are specific checklists for day schools or uh, for a larger development. Then there are Swagriha, which is self-evaluation checklist, and then there is Griha for evaluation of entire cities as well. We'll focus on either the 29 or 2015 checklist. So I have shared the checklist, both the 2019 and 2015 checklists in our shared folder as well for you to see. So if you want to see the checklist, you can either download it from here, or you can even go and get it from our shared folder. So this is the 2015 feasibility checklist. So here you can see there are several aspects related related to uh, the building sustainability and energy efficiency, and you can see for each section there are certain numbers of points which can be awarded to the building, and then you in the next section you can write that does your building satisfy that criteria or not, is it or then you can award certain points for your building or your project. So for example, you can see there is site planning. In site planning you can see uh, there are several options like site selection, so how you've selected the site. There are options for so there are points for that. Then are you opting for a low impact design? Then are you trying to mitigate urban heat island effect through your site planning? And then what are you trying to do so that you try to uh, uh, maintain minimum imperviousness possible in your site? So things like that. Then there are points for construction management. Similarly, there are points for energy, so energy efficiency, renewable energy utilization, etc. Then points for occupant comfort and well-being, so things like daylighting and maybe thermal comfort, etc. Those things are there in this. Then comes the water section. So this is what our question is asking about. Our question is specifically asking that uh, uh, it's specifically asking about the reduction in water consumption. So if we see here, uh, so this question, this section is about low flow water fixture systems, and again this is talking about uh, reduction in water demand. So water demand is how much the building will need to consume. Uh, so again, demand is basically talking about the consumption of water that will be done by the building. So again, we can see that this section is talking about water consumption in the building, as it talks about water demand. So it has three levels. So if your building has installed certain low flow fixtures and systems which enable the water demand of the building to be reduced by 30%, then if it is only till 30%, you do not get any points. But if the water reduction has been done by 50%, then you get 2 points. And if there is a reduction in water consumption or water demand by 70% or below, then you get 4 points. So if you have reduced the demand from 30 to 50%, you get 2 points, or if you have reduced the demand from 50 to 70%, you get 4 points according to this criteria. Then there is reduction on the landscape water demand. So landscape water consumption, you have 4 additional points for that. Then there is criteria for water quality and on-site water reuse, and again for rainwater recharge. So among these, we can see there are only 2 options where points can be awarded. One is for reducing landscape water demand, and another is using low flow fixtures and systems for reducing the water consumption or the water demand in the building. So you can see here the only option which we can see which is talking about water consumption in the building is low flow fixtures, which was associated to that. Again, you have the Griha manuals also. So apart from the checklist, you can even access the manuals if you want to go into detail about each of those sections in the self-evaluation checklist. So for example, this is the first version, and then this is the 2019 manual. So if you just click onto that, you can access these manuals as well, and these show you in detail about each of the criteria. So as you saw, this is the number of the criteria. So each criteria here has been explained in detail in this manual. So if you have any doubts about how many points to award in which criteria, you can access this manual and you can study each criteria in detail if you want to know how much points should be awarded, and on what how do you decide that, okay, because the building is meeting this much requirements or this benchmark, these many points I can award. Okay, so see, this shows you again it is the same section wise weightage, and then each section has a certain number of criteria which shows you the criterion structure. And then it this tells you that each criteria has 2 sections. First is the intent, that what Griha wants to achieve by evaluating each criteria, and then is the appraisal, that how you appraise or how you decide that if your building or your project meets the certain criteria or not. Then there are also compliance, so how you study compliance. Then details to the appraisals are also there, and then there are some cases of sample documentation also, to give you an example that this is how it can be documented, a certain criteria can be documented. So for example, you can see here criteria first is green infrastructure. So it talks about green infrastructure, how you can do the appraisal, how you can see the compliance. Then similarly for low impact design strategies, uh, designed to mitigate UHI, things like that. Again, you can further go through this manual uh, at your own time. Okay, coming back. So basically this question is talking about reduction in water consumption, which we saw is associated with low flow fixtures. Okay, can anyone tell me what low flow fixtures are? Any one of you? You can either write in the chat box or unmute yourself and answer.
Like double tap water fixtures and water closets also with double tap.
What is that? Double tap?
Means like there is a two tapping now. One is half flow and second one is full flow.
Okay, okay,
It's according to requirement.
okay. Anyone else?
And there is a one device we used, air mixture, that is also help us to reduce the flow rate
Yes,
and
very
increase the velocity.
yes, very good. So Yogendra told us two very good examples or low flow water fixtures. So low flow water fixtures are basically certain kind of water supply or water fixtures which actually reduce the amount of water that comes out of the fixtures or that comes out for use. So it reduces the amount of water that is coming out compared to a normal water fixture. So like Yogendra said, there are fixtures which have either a high flow or a low flow option. So if you don't want a lot of water, you can select the low flow and you can have a smaller quantity or smaller or a lesser flow of water. Or if you when you want a higher flow or higher quantity of water, you go to the high flow option. Again, as Yogendra said, there are options of mixing air into the water flow or water stream, so that lesser amount of water is needed as compared to a water fixture in which only water is there, no air is being mixed into the stream. So these are some examples of low flow fixtures. Basically their goal or the aim of such fixtures is to reduce the water that is coming out of the water fixture, so that even uh, uh, that even if you use lesser amount or lesser quantity of water, the job is being done. So those are what low flow water fixtures is, and that is what this particular criteria of Griha building rating tool measures. That what are the different kind of fixtures that you have used in your buildings, and what is the percentage of water consumption that the fixtures will reduce in your particular building. So I hope that is clear. We move on to the next question. So the next question is, which architect designed a building material that looks like flexible skin or leafy breathable structures? So this is talking about a particular building material which one of these architects have designed and used in their installations or in their design, which looks like a flexible skin or a leafy breathable structure. So Charles Correa, I think most of us know. He was a renowned architect, an urban planner, and an activist. But the most of the focus of his work was on modern Indian architecture. He worked largely on a blend of modernist principles with traditional Indian architectural concepts and focused on incorporating elements from Indian architecture like open spaces, natural ventilation, and local materials into his design. So the materials which Korea worked with largely included concrete, brick, stone, wood, glass, terracotta, and steel, and it focused on combination of modern construction techniques with uh, traditional Indian architectural practices. So none of his works focused on any other building material apart from the ones mentioned, specifically not organic skin-like looking or breathable structures. Next, we all know Frank Lloyd Wright as well. Again, he was an architect and he worked mostly on organic integration of the building with natural environment and a departure from traditional architectural conventions that building is separate from the environment in which the building is located. So he tried to harmonize architecture with natural environments, but again he focused largely on concrete, brick, stone, wood, glass, and copper. So although his designs or his buildings are examples of organic architecture, as he tries to blend his designs into the natural environment. But again, his works largely focus on materials like concrete, brick, stone, wood, glass, and copper, and not uh, different or innovative building materials. Then we have Laurie Baker. So Laurie Baker again was a British-born Indian architect who made significant contributions to sustainable and low-cost architecture in India. He focused largely on pioneering eco-friendly and cost-effective building techniques. So you can call the structures created by Charles Correa as breathable structures, as they focus on evapotranspiration throughout the building walls. However, he used mostly locally sourced and cost-effective building materials appropriate for the local climate, which include brick, stone, wood, mud or earth, bamboo, and some other recycled materials. So his focus was on simplicity, sustainability, and affordability, and prioritizing locally available resources and traditional building techniques. He did not focus on innovating any different kind of building material or other breathable structures. Although his structures, because they incorporated natural materials, they can be called breathable structures because they focus on the concept of evapotranspiration and cooling from those techniques. However, he did not focus on developing a different kind of building material, but only used locally sourced and what you call vernacular building materials. Then is Neri Oxman. So Neri Oxman is an Israeli-American architect, and she is known more for material ecology and digital fabrication rather than for her architectural designs. So she is the one who actually focuses on developing innovative building material from her explorations of material systems that are inspired by nature. So she integrates principles from biology, engineering, and technology to create certain sustainable and environmentally conscious structures and products. And these include biomaterials, biocomposites, 3D printed biopolymers, even bio-inspired fabrics, and they emphasize on things like sustainability, biomimicry, and advanced fabrication techniques. So several of the building materials that she has devised or created, they do look like flexible skin or leafy breathable structures, and she has created them from organic or plant material. So this is an example of her work. So this is the Aqua Hoja, or the bio polymer pavilion that she has created, and this again explores the use of biomaterials derived from various sources like the root structure of the fungus, algae, bacteria, and biological organisms like seashells. So, for example, this building structure has largely used these three components or these three materials, which is the chitosan. So chitosan is a derivative material that comes from the outer skeleton of shellfish. It also uses cellulose, which is a plant derivative, comes from plant material, and pectin, which is again a plant derivative, comes from plant material. So these are some uh, different materials or biopolymers that she has created in order to create this structure. So, for example, one of the components is 3D printed cellulose. So she has 3D printed cellulose to create this mesh like structure. Similarly, this is 3D printed chitosan over pectin, and also only 3D printed chitosan. And then she has also created textile like network of chitosan, or even cellular network based on these components. And from these uh, biopolymers, then she has used that material to create structures like this biopolymer pavilion. So this is what this question is talking about, uh, which is a building material that looks like flexible skin or a leafy breathable structure. If you want to read further about Oxman's project, I have linked her website. So this is her website, which showcases her projects. So, for example, this is one of the project. This is the alcohol project which I showed you. So, you can see the details about the project, in which year it was created, its location, the position, the concept behind using the certain materials. Also, it talks about the composition of various biopolymers. So you can see the composition varies in each kind of biopolymer that she creates. So you can see here, this is chitosan, cellulose, and maybe two other uh, uh, the natural objects that she makes to create these kind of biopolymers. So you can see, so this is the biopolymer, this is what it looks like, and what is the uh, uh, mix or consistency of different natural elements that she used in construction of the particular biopolymer. See here. Then she gives you details or background about where the material comes from, and then detail about the materials that she has used, the process of creating the material. So either it has been 3D printed, or it has been created in a cellular network like this, or in a textile like network like this. This all goes into the detail. So if you want to read further about her work and how she creates these kind of structures, you are free to go visit this page. And this is just one project. You can read several other projects on several other materials that have been created by her and her team. Coming back, so we move on to the next question. So our next question is, what is energy performance index? So you have several options, and the options largely talk about the formula of the energy performance index. So It asks you whether the energy performance index is uh, partial energy upon total energy consumed by a building over a year, or it is total energy consumed in the building over a year divided by the total built up area, or the total energy consumed in a building over an year divided by the total site area, or the total energy upon partial energy multiplied by building built up over the area over a year. So, energy performance index is basically a metric that is used for benchmarking energy usage in commercial buildings, and this is the formula. So, the formula is the total energy that is consumed by the building in a year divided by the total built up area of that building. So, you get the EPI in kilowatt per year per meter square. So, most commercial buildings in India have an EPI between 200 to 400 kilowatt hour per meter square per year, and this is how it is calculated. So, I hope this is clear. The national benchmark which we have for EPI is 180 kilowatt per meter square per year, and buildings with an EPI with an EPI of 180 are ECBC compliant. So this is again an example which shows you how EPI can be an effective tool for measuring if uh, or how the building is performing in terms of energy usage. So if a building is performing or using an energy consumption devices, or it is consuming energy as usual, this is the certain amount of EPI that the building will have. Then if it introduces passive measures, the EPI of the building reduces, and then it further reduces if the building introduces energy efficiency in cooling and lighting as well. So if you want to read further about EPI performance and how to reduce the EPI of a particular building, then you can visit this link. So this tells you about various aspects related to design of buildings and what measures you can take to reduce the EPI of a building. There are even case studies related to how various buildings have reduced their EPI. For example, this is the case study of uh, affordable housing in Rajkot. So this again tells you details about the project, the built up area, and the kind of techniques used to reduce the EPI of the building. So you can go through that. There are other examples. For example, this is a case study of Aranya Bhavan. This is case study of an institute, which is the Institute for Democracy and Election Management in Delhi. And this is example of a hospital building in Pune. So if you want to read further about how various buildings can reduce their EPI and increase energy efficiency, you can go read these. Okay, moving on to the next question. So next question is, the wrapped around tree trunk design for tree houses was designed in which country? So this question is particularly talking about this project, which is the yellow tree house. Uh, so this follows a concept in which the structure is wrapped around the trunk of a pine tree, and the structure is supported via the tree itself through metal cuffs, which support the structure, which is made out of glued laminated pine fins, and rods are driven through the trunk in a way that it supports the structure as well, but also doesn't constrain the growth of the tree. So this is the Yellow Tree House, which is constructed in Auckland, New Zealand, and it is constructed by the Pacific Environments. So I have linked their website here as well if you want to read further about this project. So this gives you the details about the project. What is their concept, what is the construction technique that they have followed, the environmental impact, and the various awards that this project has. Okay, so I hope this is clear. This design is in New Zealand. The next question is, Suzlon One Earth building is located in which city of India? So this is basically talking about the Suzlon Energy Limited, which is a world-leading wind energy, which is based in Pune, India, and together with their architect, they pledged to create the greenest office in India. And this question is basically talking about that, which is Suzlon One Earth. So this is the building. If you want to read further details about the building, I have linked this page. So this basically tells you about the building, uh, its plan, its construction. Uh, the building also has a 5-star certification from GRIHA, and it has become significant example of energy efficient buildings in India. So we see a lot of examples from other countries, but this building is one example of a sustainable or energy efficient building which is located in. So if you want to read further about the building, you can visit this link which I have shared. Okay, moving on to the next question, which is as per the design integrated process, what percentage of energy efficient and cost effective design can be achieved if architect, engineer, and the client all work together? So this basically talks about the fact that a lot of the design and construction process of the building design and construction is uh, taken up in parts, and some part is dominated by the architect and the client, and another part is largely dominated by another professional like the engineers or the electrician or the HVAC experts, etc. So the integrated design process, this concept focuses on the thing that the integration of multiple professionals and multiple aspects of building design and construction should be done from the beginning itself, so that everything can go in tandem, and there needn't be any changes or any mismatches in the building design and the amount of energy or amount of resources a building is using, so that the building can save up on energy efficient and cost effective design. So according to experience of professionals, it has been seen that during the concept design process or the building design process, largely the client and architect are only involved, and the structural engineer, HVAC engineer, and other consultants are less involved during this process, and they're involved in the later part when the construction drawings and construction and commissioning of HVAC, etc., are taking place. What has been seen, that if the structural engineer, HVAC engineer, and other consultants are involved from the beginning, 25 to 40% of savings can be done in uh, both energy and cost effectiveness, with no marginal increase in the cost that comes to the client. So this is what this question is asking about, that what percentage of energy efficiency or cost effectiveness in the design can be achieved if all the different professionals work in an integrated design process for the design and construction of the building. So This is the number which has been seen uh, by experience, that this is the amount of savings in energy and cost efficiency that can be achieved. Okay, moving on to the next question, which is strategic interventions to increase energy efficiency in buildings can be achieved by doing which of the following? I have four options: low maintenance site development and site grading for water systems, both of these, or none of these. So this is basically talking about what kind of different interventions that can be taken for achieving energy efficiency inside building. So low maintenance site development, obviously you can save energy or you can have an energy efficient building if you opt for low maintenance site development, because then you don't have to use a lot of energy in development of the site. You make minimum possible changes to the site, minimum possible interventions in the site, and because of that you have to use the least amount of energy for maybe the earthwork, maybe the foundation in the site, and because of that you use lesser amount of energy. Then there is site grading for water systems. Again, if you grade your site according to the slope, the contours, and the kind of um, uh, water supply and sewerage arrangements which are there on the site. If you grade your site according to that, again you have to use less amount of energy in pumping the water on your site and in pumping the sewerage out of your site. So you can see if you can see this comes from this diagram which was discussed in the lecture. So you can see low maintenance and low maintenance site development, which is one part of producing energy efficient buildings, and another part is site grading, which is maintaining the natural site drainage in order to reduce the load of energy that will be used by the building, either for pumping water or for pumping sewerage out of the site. So I hope that is clear. Thank you. This was the last question for today. Thank you all for attending. Now I'll take any doubts. If you have any doubts, please go ahead and ask.
Can I ask a question, ma'am?
Yes, please.
I'm sorry for I was late because I was stuck in traffic actually though. I was just saying maybe if we can get a summary of what was discussed or maybe the topic like so I'll do a research on that.
So, I do not have a summary to all of this, but all of the sessions which I take here, these are recorded and then these are shared on YouTube. So, every session that we take here, the session is recorded and then shared as a YouTube video. So you can access the session there, and in the end of the session, like after every session, I shared the material in a common folder as well. So we have a common folder available on the Swayam website, and from there you can access the folder. You can access all of the material which I discussed here. I hope that is clear.
Yes, ma'am. Thank you very much.
So, if you do not know, we are discussing some uh, problems or some example problems from this week's lecture, and we tried to see how you can use the background material from the week and solve some sample questions using that background material. So that is what was discussed. If you have any doubts about the lecture that were covered this week, you are free to ask.
It's okay. No problem. Thank you very much, ma'am. I think I'll have to check it out and then go to it.
Anyone else has any doubts? I hope everyone knows where to access the pre-recorded sessions and the shared material.
Except for me, I don't know. Can you help me with that one? Where can I access? Like, I also missed the last class, the last
Okay,
session with you.
okay, I can show you.
Okay.
So this is your SWAM website. So I think you know that in if you go to the portal, you from here you can go to my courses, and that will take you to this page. So this is our course, which is the strategies for sustainable design. If you go to the course, you have this page open up. In the end of the page, you have this problem solving session. So if you click on to here, you see the recording of the problem solving session. So if you click on to here, you come to this page, and here is the link for accessing uh, the lectures. So this link will take you to this page, and here there are links for each week's videos. So these are the last two weeks videos, and this is the link to our shared folder. So this is a drive folder, and this is our shared drive folder where I share all of the material which I am sharing. So these are the two presentations from the previous 2 weeks, and this is the additional material which I shared so far. I
All right,
hope.
okay. Thank you very much. I now understand.
Anyone else? Anyone else has any other doubts?
Yes, Nikhil, myself Tanmay. I just want to know that the course coordinator video, that is subject week-wise video, whatever uploaded, and what you taught us this presentation, both are same or some updated version of that, or only this is a problem solving.
This is only the problem solving. I am not telling you anything which is different from the one that is being shared in the lectures. Maybe
Hmm.
I'll give you some updates. So for because the lectures were recorded, I think in 2015, and
Yeah.
from 2015 there has been a lot of updates on the information that is being shared. For example, who are the world leaders in energy consumption, what is the percentage of energy consumption by each sector, even the Griha, the lectures talk about Griha. So earlier we were using Griha 2015 manual. The Griha manuals have changed now. We have a newer 2019 manual. So some updates like that I'll share. Otherwise, it is
Okay.
mostly what is there in the lectures itself. I'm not
Yeah.
telling you something which is new or different from the
Yeah,
lectures.
that's okay. Here, just my submission is that in the whatever the video of course coordinator presentation he discussed, and that detailed transcription is available in week wise. So if we need only the presentation content to the specific study of those points, so is it can you make help on that point to share the specific PPT as just like you have presented right now?
Okay,
The
so you're basically asking that instead of the
uh,
transcript, you want
description,
the
yeah,
presentations. So
yeah,
actually, if you want to request that, I don't know if you are aware, there is a discussion forum on the SWAYAM portal itself. Are you
yeah. I
aware?
know, I know, I know,
Yes. So
I
you
know.
can ask the course instructor about that in the discussion forum itself. You can directly contact the course coordinator, and you can ask for the presentation or the handouts from them.
Because the transcription version is a lot of page, so it's a huge content.
Okay,
So
okay, so you can
specifically,
directly ask the course coordinator to give you handouts if you want that. You can directly ask in the forum.
okay, thanks, thanks, guiding.
Any other questions? Seema is asking what is the syllabus for minor exam. Uh, I don't know. I think there is only one exam. I'm not aware if there are any minor exams for this subject. Let me check.
Hello,
Yes.
ma'am. You have any study material for this course, like some notes and other data?
Uh, I don't actually get. Just give me one moment, then I'll come to your question. So I think all of you can see my screen. I don't think there is a minor exam. There is only one exam, which is the exam at the end. So this is how this is what the criteria is there to get your certificate. So you get awarded points based on your assignments, and you also get awarded points based on your exam. So exam will be at the end, at the finish of this course. So 75% of your points will be based on how you performed in the exam, and 25% of your score will be based on how you scored in the assignments. So the best 8 assignments of your total submissions would be taken for calculating your scores in the assignments, and 25% of that average score will be taken towards your final certificate score, or your final score. And there is only one exam. I don't think there is any minor exam. If you still are unsure, you can either write to the NPTEL staff or to the course instructor and ask about that. Seema is asking that your university exam is in the first week of March. Okay, Seema, I think the university exams, they have a different pattern than NPTEL. NPTEL has only one exam, and your score be there. Uh, will be decided on based on that exam and your assignments only. There is no other minor exam. So university has separate courses, and they run separately than NPTEL course, which is this. Okay, coming to Yogendra's question. Can you repeat your question again, Yogendra?
Ma'am, can you share any some study material for us for this course?
So whatever I study material which I show, which I give, which is additional, is shared in the folder itself. The shared folder which I showed you, I am sharing everything in that folder only.
Okay, thank you.
You really don't need any additional or other material. Whatever is being given out in the lectures, and as the transcripts or any other handouts by the course instructor, that is all you need. Apart from that, we have discussion sessions or problem solving sessions. So if you have any doubts, you can ask your doubts there, but you really do not need much additional materials. There are some books and some materials which have been shared by the course instructor, I think, in the Swayam website itself. So if you want to see that, you can go ahead and see that. For example, you can see here, this is the book section. I think some books have been shared by the course instructor. I don't think that link is opening. I think either there is some problem with this link or it's an empty file, but this link didn't open. So largely whatever you need for your assignments or for your exams or whatever you need any information about this, that is largely covered in the lectures, and any additional material or anything else, if you still need further, you can directly contact the course instructor. I cannot really give you more information which hasn't been approved by the instructor. So if you want any further study material, I suggest you should directly contact the course instructor. Hima is saying that either morning session or afternoon session, depending on availability of slots at exam center. Okay, you're talking about the exam. Okay. Anyone else has any other doubts? If anyone still has any doubts, are you sharing the PPT today? Yes, I'll share this PPT today itself. If anyone else still has any further questions, please go ahead and ask. If there are no further questions, should I close the session for today? Okay. What about others?
Thank you, ma'am. Thanks.
Okay, I think I'll close this session for today then. Thank you very much. Thank you all for attending, and I'll see you next week, same time, 6 p.m. to 8 p.m. Goodbye.